Hi everyone, I'm Kenichi Ota, CEO of Kenix System. In this video, I'd like to explain the excellent concepts behind our LCD controller. The target users of our product are electronics manufacturers who need to produce small quantity lots and continue production for a long period of time. Also, OEM designers of electronic equipment will be interested in this video as well. Our LCD controllers have received strong support from three main fields of customers: medical, shipping, special measuring equipment. Kenix System has an excellent 16-year track record in Japan. When installing the LCD in your company's product, I believe you will encounter three problems. I think the first problem is what to do about the interface between the host CPU and the LCD. In other words, this is a question about the structure of the hardware. I think the second problem is how to build the software even after the hardware setup has been decided. Of course, you'd like to minimize costs such as software licenses, right? The third problem is product discontinuance. This happens when the manufacturer ceases production with LCD, CPU, LCD controller, or other parts. In these cases, the problem is much more severe than the discontinuance of the capacitor and resistor. This is a greater impact on the PCB and software. Well, these three problems can be solved by using our LCD controller. Please allow me to explain in a little more detail. Take a look at this picture. This diagram represents the basic structure of our LCD controller. See, it's very simple, isn't it? However, do you remember seeing this somewhere before? That's right. Epson's LCD controller for small and mid-sized LCDs has just about the same basic structure. Even though our LCD controller has a similar structure to our competitors, we offer a much better value. This is because it's a lot easier to understand and master our products. For example, most of our user manuals provide complete documentation in only 40 pages. You can finish building hardware by designing in the same way as static RAM with a wait signal. So you can forget about LCD controller which instruction manuals has 100 of pages long. Kenix System's LCD controller is used by connecting a frame buffer for image memory. From the host CPU, this seemingly appears as its own local memory. For example, when writing some data to address number 0 of the frame buffer, a colored pixel of the data is displayed at the upper left, and when writing to address number 1 of the frame buffer, the pixel is displayed 1 pixel to the right from the upper left. Thus, it's very simple. Additionally, you don't have to consider the write timing. The bus timing allows write at any time. Therefore, based on the pixel drawing function, we have a lineup of LCD controllers that executes all drawing via to software, and these controllers are low cost. We have another lineup in which the LCD controller itself carries out the box fill and photo drawing function instead of the CPU. We call this function the tiny accelerator. By using this tiny accelerator, software development is an ease. When producing equipment with LCDs, you are often afraid of the discontinuance of the LCD and LCD controller. I'm sure many viewers have experienced how often LCD specifications change. Even with the Japanese manufacturers, there have been 2 changes of the driver chip in only 3 years. So how should we face this reality? To tell you the truth, externally, our LCD controller seems like a dedicated chip, but it actually contains an FPGA. we are buying one for our company only from an FPGA maker. Therefore, it can flexibly support a change of LCD design or a change in the driver chip. In addition, since software designed using our concept requires no OS, even if the CPU is discontinued, porting to another one is very easy. Kenix Systems LCD controller can really bring down the overall cost for the entire life cycle of the product. I will demonstrate the advantage by introducing an example of the projected cost. Let's consider an example in which a medical device manufacturer introduces an LCD controller to a device that has a protection number of 100 units per month. Check this out. I calculated the lifelong maintenance cost of a product using the chip from a certain LCD controller manufacturer, focusing on only the LCD. Development cost for quarter VGA LCD part 4 months. 3 design changes while producing for 12 years. 2 months times 3 changes equals 6 months. PCB design change 3 changes. As shown in this table, the total is 10 months. On the other hand, when using Kenix Systems chip, development cost for quarter VGA LCD part 2 months. Design changes for production over 12 years 0. PCB design change 0 changes, nothing. The above total is 2 months. For industrial equipment manufacturers which need to produce small quantity lots, these labor costs and design change costs serve as a very big burden. When using the dedicated chip, it is also an illusion that the unit price falls sharply in the case of small lots. Recently, a kind of CPU with a built-in LCD controller is increasing. When making a careful choice, I think it is worth it. Even in this situation, you should assume the case where the CPU becomes a stoppage in production. For example, certain manufacturers judged that cannot change designs of many models more than the problem of development cost when they increase the lineup too much. Therefore, they decided to introduce our LCD controller. Of course, there are many different system configurations, so I recommend you to consider and calculate for your own specific needs. Okay, I hope you can now understand what an excellent concept we offer. I'll now briefly describe Kenix Systems LCD controller lineup. Our LCD controller covers all small and mid-sized LCDs ranging from 320 by 240 pixels to 800 by 600 pixels. And we also offer an LCD controller with a built-in LVDS. For more details, please refer to our website www.kenix.co.jp/w. Well, that's a wrap. Thanks for watching and see you later in another movie.